Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the lesson on integration by parts, and in this video I'm going to be taking you through a more complicated example than the first one. So here we have, we are going to be integrating 4x cos squared x with respect to x. And the reason this one is more complicated than the previous example is we have to think about how we're going to deal with the cos squared. But the same rules apply as in the previous video. We're going to call the simple bit u. So we're going to say that u is 4x, and we're going to call the other part dv dx. So dv dx is cos squared x. So differentiate to get du dx, which is 4. And integrate to get v. Now I need to think about how to integrate cos squared x. Now the way to do it, and I would encourage you to remember this, is to swap cos squared x to a half plus a half cos 2x. Now the reason that works is one of the double angle trig identities that you need to be familiar with is that cos 2x equals 2 cos squared x minus 1. And if you rearrange that to make cos x the subject by adding 1 and dividing by 2, you end up with a half plus a half cos 2x. So again, one I would encourage you to remember. The other identity that we can use for cos 2x is 1 minus 2 sine squared x. So if we were trying to integrate sine squared x, that would be a half minus a half cos 2x, because if you rearrange this, the only difference is going to be that sign there. So two worth remembering in my opinion, cos squared and sine squared. So rather than integrating cos squared x in this form, I'm going to integrate a half plus a half cos 2x. A half integrates to a half x, and a half cos 2x integrates to 1/4 sine 2x, because cos integrates to sine, and then we're dividing by 2 because of the coefficient of x within cos. So here we then have everything that we're going to be needed to use for our integration by parts. So the integration by parts formula that you need to write out each time you are using it, the integral of u dv dx equals uv minus the integral of v du dx. So the original function that we were trying to integrate was 4x cos squared x with respect to x. Now uv, so u is 4x and v is this whole expression here, so a half x plus 1/4 sine 2x minus the integral of v du dx. So what I'm just going to write here, I'm going to put du dx first because it's 4 lots of v, which is this whole term again, half x plus 1/4 sine 2x with respect to x. So here we are. So I'm just going to tidy this up a little bit and then deal with integrating the second part. So 4x multiplied by a half x is going to be 2x squared, and 4x multiplied by 1/4 sine 2x is going to be plus x sine 2x. And there's no further integration required on this part. We're just going to be integrating this second part. But before I do that, I'm just going to expand it out. 4 lots of a half x is 2x, and 4 lots of a quarter sine 2x is sine 2x. And I'm now going to integrate both of those terms with respect to x. Not forgetting, I've still got this 2x squared plus x sine 2x. And now we're subtracting the integral of this here. Now notice, subtract big square bracket because I'm going to be subtracting the result of both terms here, and I just need to be careful with signs. So integrate 2x, you're going to get x squared. And integrate sine 2x, now sine integrates to negative cos, and we divide by 2 because of the coefficient of x. So minus a half cos 2x plus constant. Now I just need to think about tidying this up with what's going to happen at the end. So I've got 2x squared, take away x squared. So my final result, I'm going to have x squared plus x sine 2x. And now here I'm subtracting negative a half cos 2x. So that's going to be plus a half cos 2x. And not forgetting plus c. So there we are. Integrate 4x cos squared x. Final result, x squared plus x sine 2x plus a half cos 2x plus c. Key points to note along the journey: how to integrate cos squared x using that swap, that's one to learn. And then when we get down to this stage here, subtracting both terms and just being careful with your signs for your final expression. Right, I'll see you in the next video.